@NCERT video welcomes you. Today we are going to start Chapter 8 Playing with Constructions. Let's start Chapter 8 Playing with Constructions. Eight point one Artwork. Observe the following figures and try drawing them freehand. You have to draw these figures freehandly. Figure 8.1. Now arm yourself with a ruler and a compass. Let us explore if we can draw these figures with these tools and get familiar with a compass. Using a compass and a ruler, this one is compass and this one ruler, you can draw the figures given in 8.1 easily. Observe the way a compass is made. What can one draw with the compass? Explore. Using a compass, one can draw an arc or a circle or any curved figure made using arcs and circles. Do you know what curves are? They are any shapes that can be drawn on paper with a pencil. You can see curves here. This is called circle. This is called line segment. And include straight lines, circles and other figures as shown below. Mark a point P in your notebook, then mark as many points as possible in different directions that are 4 cm away from P. You have to mark point P and mark other points which are at a distance of 4 cm from P, such as Q and R. Like this. Imagine marking all the points of 4 cm distance from the point P. How would they look? They will look like a circle. Point P will be called center of the circle and radius is equal to 4 cm. You will get a big circle like this. Try to draw it and verify if it is correct by taking some points on the curve and checking if their distances from P are indeed 4 cm. All the points on the circle will be at a distance of 4 cm. Explore if you have not already done so and see if a compass can be used for this purpose. You can start by marking a few points of distance 4 cm from P using the compass. How can this be done? You have to take 4 cm as distance between pencil tip and compass tip and draw a circle like this. P will be the center of the circle and distance from P to the Any point on the circle will be radius. You will have to open up the compass against a ruler. See figure 8.2. Figure 8.2 like this, such that the distance between the tip of the compass and the pencil is 4 centimeter. Now try to get the full curve. Hint: keep the point of the compass fixed, moving only the pencil. What is the shape of the curve? It is a circle. Take a point on the circle. What will be its distance from P? Equal to 4 centimeter, less than 4 centimeter, or greater than 4 centimeter. Distance from the point P to the circle will be equal to 4 centimeter. Similarly, what will be the distance between point P and another point on the circle? It will be always 4 centimeter. As shown in the figure, the point P is called the center of the circle, and the distance between the center and any point on the circle is called the radius of the circle. Having explored the use of a compass, go ahead and recreate the images in figure 8.1. Can you make the figures look as good as the figures as shown there? Try again if you want to. You can redraw the figures given in figure 8.1. Also, has the use of instruments made the construction easier? Now try constructing the following figures. Using ruler and compass, the figures given in figure 8.1 will be easier to draw. Construct 1. A person. How will you draw this? This figure has two components, head and body. You might have figured out a way of drawing the first part. For drawing the second part, this is like this. You can draw the first part using ruler and a compass, and the second part can be drawn like this. But it will be difficult to locate this point. It should have equal distance from these 2 points. The challenge here is to find out where to place the tip of the compass and the radius to be taken for drawing this curve, this one. You can fix a radius in the compass and try placing the tip of the compass in different locations to see which point works for getting the curve. Use your estimate where to keep the tip. You have to try and try for this point. 2. Wavy wave. Construct this. As the length of the center line is not specified, we can take it to be of any length. You can take any length for this line segment. Let us take AB to be the central line such that the length of AB is 8 cm. We write this as AB is equal to 8 cm. Here the first wave is drawn as a half circle. First, you have to draw a line segment of 8 cm like this, and then you have to mark a point in the middle of 8 cm, that is at 4 cm as x. Center of A and x will be the center of the circle, that will be at a distance of 2 cm from A or 2 cm from x. Taking this point as a center and a radius of 2 cm, draw a semicircle or half circle like this. Similarly, taking this point as a center, which is at a distance of 2 cm from x and b, you can draw another half circle like this. Figure it out. 1. What radius should be taken in the compass to get the half circle? What should be the length of AX? The answer is radius will be 2 cm and the length AX will be 4 cm. 2. Take a center line of a different length and try to draw the wave on it. 3. Try to recreate the figure where the waves are smaller than a half circle, as appearing in the neck of the figure a person. The challenge here is to get both the waves to be identical. This may be tricky. 3. Eyes. How do you draw these eyes with a compass? You can draw arcs like this using compass. Please note that these 2 points should be in the same straight line. Similarly, draw a perpendicular like this on these 2 points and take this distance as the radius and draw 2 curves like this from 2 points lying in a straight line, and then you can draw a circle in the center and paint it. Another way of doing it is draw a straight line, then draw 2 lines perpendicular to it, and then take 2 points on this line as well as on the another line as center and draw arcs like this. Then you have to draw dark circle in the center for eye. For a hint, go to the end of the chapter. Make other artwork of your choice with a ruler and a compass. 8.2 Squares and rectangles. Now let us look at some basic figures having straight lines in their boundary, such as squares and rectangle. Figure 8.3. You can see these shapes has a straight line as their outer boundary. What shapes are these? Yes, these are our familiar squares and rectangles. But what makes them squares and rectangles? Consider this rectangle ABCD. The points A, B, C and D are the corners of the rectangle. Lines AB BC, CD and DA are its sides. Its angles are angle A, angle B, angle C and angle D. The blue sides AB and CD are called opposite sides as they lie opposite to each other. Likewise, AD and BC is the other pair of opposite sides. AB and DC are opposite sides. Similarly, AD and BC are opposite sides. Recall that in a rectangle, rule R1, the opposite sides are equal in length, and rule R2, all the angles are 90 degrees. As in the case of rectangles, the corners and sides are defined for a square in the same manner. A square satisfies the following two properties. Statement S1, all the sides are equal, and statement S2, all the angles are 90 degrees. See the rectangle in figure 8.4 and the name given to it, ABCD. This rectangle can also be named in other ways. BCDA, CDAB, DABC, ADCB, DCBA, CBAD, and BADC. If you see a rectangle ABCD, its naming should be such that it follows a direction of clockwise or anti-clockwise starting from any point. For example, this rectangle can be named as ABCD or ADCB or BCDA or BADC or CDAB or CBAD. Similarly, DABC or DCBA. No points should be left in between. So, can a rectangle be named using any combination of the levels around its corners? No. For example, it cannot be named ABDC or ACBD. Can you see what names are allowed and what names are not? In a valid name, the corners occur in a order of travel around the rectangle, starting from any corner. Which of the following is not a name for this square? 1. PQSR. PQRS. Since this name is not in a continuous sequence of corners, so this will be not a name for this square. It should be PQRS. So PQSR is wrong. 2. SPQR. SPQR. This is correct. 3. RSPQ. RSPQ. This name is correct too. 4. QRSP. QRSP. This name is also correct. Rotate squares and rectangles. Here is a square piece of paper having all its sides equal in length and all angles equal to 90 degree. It is rotated as shown in the figure. Is it still a square? Yes. Let us check if the rotated paper still satisfies the properties of a square. Are all the sides still equal? Yes. Are all the angles still 90 degree? Yes. Rotating a square does not change its lengths and angles. Therefore, this rotated figure satisfies both the properties of a square and so it is a square. By the same reasoning, a rotated rectangle is still a rectangle. Figure it out. 1. Draw the rectangle and 4 squares configuration shown in figure 8.3 on a dot paper. What did you do to recreate this figure so that the 4 squares are placed symmetrically around the rectangle? Discuss with your classmates. 2. Identify if there are any squares in this collection. Use measurements if needed. Figure A: 1 unit, 2 unit, 3 unit, 4 unit. One side length is 4 unit. Similarly 1, 2, 3, 4. 4 unit this side. 1, 2, 3, 4. 4 unit this side and 4 unit this side. And corner angle half of straight angle. You can see it here. That means corners right angle or 90 degree each. So figure A will be a square. In the second figure, you can see the corner angle is more than 90 degree. So this is not a square. In third figure, you can see corner angle is more than 90 degree. So this is not a square. In fourth figure, you can see side lengths are not equal. So this is not a square, though its corner angle is 90 degree. Since its opposite sides are equal, it will be a rectangle. Think it is it possible to reason out if the sides are equal or not and if the angles are right or not without using any measuring instruments in the above figure? Can we do this by only looking at the position of corners in the dot grid? The answer is yes. You can see it here. On a dot grid, you can easily identify whether a figure is a square or rectangle without using compass, ruler or protractor. 3. Draw at least 3 rotated squares and rectangles on a dot grid. Draw them such that their corners are on the dots. Verify if the square and rectangles that you have drawn satisfy their respective properties. 8.3 Constructing squares and rectangles. Now let us start constructing squares and rectangles. How would you construct a square with a side of 6 cm? For help, you can see the following figures. A square PQRS of side length 6 cm is constructed. Step 1. Draw PQ of length 6 cm. Step 2. Mark a point to draw perpendicular to PQ passing through P. Step 3. Method 1. Mark S on the perpendicular such that PS is equal to 6 cm using a ruler. Method 2. This can also be done using a compass. Take 6 cm as distance between tip of the pencil and tip of the compass and draw an arc like this. This point will be point S. Can you see why PS should be 6 cm long? Step 4. Draw a perpendicular to line segment PQ through Q. Step 5. If we had used the compass, then the next point can easily be marked using it, like this. Step 6. Join R to S. Please note that naming here has some mistakes. This point is S. In the next picture, this should be S, this should be S, and this should be R. Such that the square name is PQRS. After joining S to R, you will get a square PQRS. How long is the side RS? And what are the measures of angle R and angle S? They should be 90 degree. And length of RS will be 6 cm. Construct 1. Draw a rectangle with sides of length 4 cm and 6 cm. First, you have to draw a line segment of length 6 cm. Name it PQ. At P and Q, draw a perpendicular like this. Using compass, draw arcs at a distance of 4 cm, cutting the perpendiculars. Join these 2 points. Your rectangle PQRS is ready. After drawing, check if it satisfies both the rectangle properties. Yes, the opposite sides are equal and corner angles 90 degree each. 2. Draw a rectangle of sides 2 cm and 10 cm. After drawing, check if it satisfies both the rectangle properties. 3. Is it possible to construct a four-sided figure in which all the angles are equal to 90 degree but opposite sides are not equal. Is it not possible to construct a figure whose all angles are 90 degree each but opposite sides are not equal? Answer will be no. You can see here only rectangle and square are the two figures where corner angles each being 90 degree and opposite sides equal to each other. It is not possible to draw a figure such that its corner angle is equal to 90 degree but opposite sides not equal. 8.4 An exploration in rectangles. Construct a rectangle ABCD with AB is equal to 7 cm and BC is equal to 4 cm. Imagine X to be a point that can be moved anywhere along the side AD. Similarly, imagine Y to be a point that can be moved anywhere along the side BC. Note that X can also be placed on endpoint A and D. Similarly, Y can also be placed on the endpoint B and C. You can see here X and Y can be placed anywhere on AD and BC respectively. In this figure, you can see distance between X and Y is maximum when X is placed at D and Y is placed at B. Similarly, when Y is placed at C and X placed at A, distance will be maximum. These lines are called diagonals. When X is placed at A and Y is placed at B, distance will be minimum and equal to side of rectangle. Similarly, X can be placed at D and Y can be placed at C. At which positions will the points X and Y be at their closest? When do you think they will be the farthest? What does your intuition say? Discuss with your classmates. Now, verify your guesses by placing the points X and Y on the sides and measure how near or far they are. The distance between X and Y can be obtained by measuring the length of the line XY. How does the minimum distance between the points X and Y compare to the length of AB? Change the positions of X and Y to check if there are other positions where they are at their nearest or farthest. You could construct multiple copies of the rectangle and try out various positions of X and Y. How will you keep track of the lengths X and Y for different positions of X and Y? Here is one way of doing it. Suppose here are some of the positions of X and Y that you have considered. When X is 5 mm away from A and Y is 3 cm away from B, XY is equal to dash centimeter dash millimeter. When X is 1 cm away from A and y is 1 centimeter away from B, xy is dash centimeter dash millimeter. When x is 2 centimeter away from A and y is 4 centimeter away from B, xy is equal to dash centimeter and dash millimeter and so on. Is there a shorthand way of writing it down? In all the sentences, only the position of x, y and the length xy changes. So we could write this as distance of x from A, distance of y from B, length of xy. Have you checked what happens to the length xy when x and y are placed at the same distance away from A and B respectively? For example, as in the cases like these, distance of x from A, distance of y from B, length of xy. You can fill the following table. Kindly try doing it, and so on. In each of these cases, observe 1. How the length xy compares to that of AB, and 2. The shape of four-sided figure ABYX. How does the farthest distance between x and y compare with the length of AC and BD? Construct breaking rectangles. Construct a rectangle that can be divided into three identical squares as shown in the figure. You can see this rectangle has been divided in three squares which are identical to each other. Solution. If this seems difficult, let us simplify the problem. The solution will be you have to take the length as 3 times width. If width is x, the length will be 3x. So you can easily divide into squares of side length x. You can see it here. The length should be triple of the width. Explore. What about constructing a rectangle that can be divided into two identical squares? Can you try it? Similarly, if you want to construct two identical squares within a rectangle, then you have to take length twice of width. If width is x, then length should be 2x. It is wise to first plan and then construct, but how do we plan? Can you think of a way? One way is to visualize the final figure by drawing a rough diagram of it. What can we infer from this figure? Can you identify the equal sides? Since the two sides are identical, that is AB is equal to BC and FE is equal to ED, you can say these two squares are identical to each other. Since ABEF and BCDE are squares, all the sides in each of the squares are equal. This is written as AF is equal to AB is equal to BE is equal to FE. BE is equal to BC is equal to CD is equal to ED. So, all the shorter lines are equal. A convention is followed to represent equal sides. It is done by putting a line on the line referred to the rough figure. You can see equal lines are shown using this type of smaller lines. Using this analysis, can you try constructing it? Remember, all that was asked for is a rectangle that can be divided into two identical squares and with no measurements imposed. To draw the rectangle ACDF, one could assign any length to AF. For example, if we assign AF is equal to 4 cm, then what must be the length of AC? If AF is equal to 4 cm, then AC will be double of 4 cm, that is 8 cm. Explore. Can the rectangle now be completed? In fact, one could proceed by drawing AF without even measuring its length using a ruler. We could then construct a line perpendicular to AF that is long enough to contain the other side. As AB is equal to AF, we need to somehow transfer the length of AF to the point B. How do we do it without a ruler? Can it be done using a compass? Yes, like this. Observe how the length of AF is measured using a compass. You can see here that distance between tip of the pencil and the tip of the compass is equal to length AF. After drawing perpendiculars to A and F like this, you can draw arcs of length AF like this. Then you can join these points where arc cuts perpendicular like this. Your figure is ready. Use it to mark out the points B and C and complete the rectangle. With this idea, try constructing a rectangle that can be divided into three identical squares. For this, you can take any length AF, draw perpendicular at A and F like this, taking arc length of AF and cut the perpendicular in three parts like this. Join these points. You can see a rectangle is ready which has been divided in three squares. Give the length of the side of a rectangle that cannot be divided into two identical squares, three identical squares. If length is not double of width, then no two identical squares can be formed within a rectangle. Similarly, if length is not equal to 3 times of width, then it is not possible to form three identical squares within a rectangle. Construct 1. A square within a rectangle. Construct a rectangle of sides 8 cm and 4 cm. How will you construct a square inside as shown in the figure, such that the center of the square is the same as the center of the rectangle? You can see here this side length is 8 centimeter and this side length is 4 centimeter. Since minimum length is 4, you can construct a square whose length and width or whose all sides will be 4 centimeter each. Since this square is in the middle of the rectangle, this length should be equal to this length. Since this length has been removed from 8 centimeter, only 4 centimeter length will remain. It should be splitted in two halves such that this length is equal to this length. So 4 divided by 2 is equal to 2 centimeter. This length should be 2 centimeter and this 2. And draw a rough figure. What will be the side length of the square? What will be the distance between the corners of the squares and the outer rectangle? 2 falling squares. You can see 3 squares here. You have to draw a figure like this. Make sure that the squares are aligned the way they are shown. Each is a square of side 4 centimeter. Now try this. Square of side 3 centimeter, square of side 5 centimeter, square of side 7 centimeter. 3. Shading. Construct this. Choose measurements of your choice. Note that the larger four-sided figure is a square and so are the smaller ones. The larger one is a square and it has been splitted in 1, 2, 3 and 4 squares, and again in 1, 2, 3, 4, 5, 6, 7, 8, like that, up to 16 squares. After drawing this figure, you have to shade it like this. And so on. 4. Square with a hole. Observe that the circular hole is the same as the center of the square. You can see if you enlarge the center of the square, you will get a circular hole like this. So you need to find the center of the square. First, you have to draw a square. Then join their opposite corners like this. You will get a center. Using compass, you can draw a circle like this. You will get this shape. Hint, think where the center of the circle should be. Another way of doing this is, after drawing a square, mark the centers of the side. Join them using dot line. The point where these lines meet is the center of the circle. 5. Square with more holes. You can draw this figure. 6. Square with curves. This is a square with 8 cm side lengths. Hint: think where the tip of the compass can be placed to get all the 4 arcs to bulge uniformly from each of the sides. Try it out. For this arc, you have to take a distance that is at an equal distance from these 2 points. To get this point, you have to take a arc length of this length, that is 8 cm. Draw arcs from these 2 points such that this length is 8 cm. Now you can draw this arc. Similarly, you can draw arcs meeting at this point, taking length 8 cm and draw arc like this. Similarly, here like this. (8.5) Exploring diagonals of rectangles and squares. Consider a rectangle PQRS. Join PR and QS. These two lines are called the diagonals of the rectangle. Compare the length of the diagonals. First predict the answer, then construct a rectangle marking the points as shown and measure the diagonals. If you measure the diagonal, you will get PR is equal to QS. And if you measure the angles using a protractor, angle A will be equal to angle E, angle A will be equal to angle H, angle A will be equal to D, angle A will be equal to E, angle H, angle D. Similarly, angle B will be equal to angle C, angle F and angle G. Angle B will be equal to angle C, equal to G, equal to F. In rectangle PQRS, the right angles at P and Q are referred to as opposite angles. The other pair of opposite angles are the right angles at Q and S. P and R are opposite angles of each other. Similarly, S and Q are opposite angles of each other, each being right angle or 90 degree. Observe that a diagonal divides each of the pair of opposite angles into two smaller angles. In the figure, the diagonal PR divides angle R into two smaller angles, which we simply call G and H. The diagonal also divides angle P into C and D. Are G and H equal? Are C and D equal? Yes. G is equal to H and C is equal to D. Indeed, all these four are equal to each other. First, predict the answers and then measure the angles. What do you observe? Identify pairs of angles that are equal. Explore. How should the rectangle be constructed so that the diagonal divides the opposite angles into equal parts? When diagonals divide the opposite angles or corner angles in equal parts, then the rectangle will be not a rectangle. It will become a square. You can try doing it. This side will be equal to this side, and this side. That means all four sides are equal, then only diagonal will divide corner angle into two equal parts. How will you record your observations? First, identify the parameters that need to be tracked. They are the sides of the rectangle and the 8 angles formed by the two diagonals. Are there any other measurements that you would want to keep track of? For this, you can fill the following table. In your experimentation, did you consider the case when all four sides of the rectangle are equal? That is, did you consider the case of a square? See what happens in this special case. What general laws did you observe with respect to the angles and sides? Try to frame and discuss them with your classmates. How can one be sure if the laws that you have observed will always be true? Construct 1. Construct a rectangle in which one of the diagonals divides the opposite angles into 60° and 30°. Solution. Let us start with a rough diagram. Your final result should be like this. This is a rough diagram. In what order should its part be drawn? We will briefly sketch a possible order of construction. Step 1. AB is drawn with an arbitrary length. What is the next point that can be located? After drawing AB, you have to draw perpendicular at point B like this. Step 2. Put protector at A and draw an angle equal to 60° like this. This angle is 60°. This line will meet the perpendicular at point C. Step 3. We know the line on which D lies. Draw a line through A perpendicular to AB. You have to draw a perpendicular on point A like this. This angle will be 30°. Measure the length BC using a compass and draw a arc taking A as center, cutting the perpendicular drawn at A. Name the point as D. Join CD. Your rectangle ABCD is ready. Now angle A divided into two angles. One measures 60°. Check what the other angle is. There are at least two ways of finding the point D. One uses the fact that all the angles of a rectangle are right angles. The other uses the fact that opposite sides are equal. You can get the point D by drawing a perpendicular at point C, like this. It will meet the perpendicular drawn at point A at point D. Step 4, Method 1. Draw a line perpendicular to BC at C to get the point D, like this. Method 2. Using a compass, mark the point D such that AD is equal to BC. Join CD to get the required rectangle. We have seen how to construct rectangles when their sides are given. But what do we do if a side and a diagonal is given? To construct a rectangle where one of its side is 5 cm and the length of a diagonal is 7 cm. Solution. Let us draw a rough diagram like this. Let us decide the steps of construction. Which line can be drawn first? Step 1. The base CD measures length 5 cm can be easily constructed like this. Step 2. Draw a perpendicular to line DC at the point C. Let us call this line L. Like this. This is easy as we know that this line is perpendicular to the base. The point B should be somewhere on this line. How do we spot it? What else do we know about the position B? We know that it is of distance 7 cm from the point D. One of the ways of marking B is by taking a ruler and trying to move it around to get a point on line L that is 7 cm from D. However, this requires trial and error. There is another efficient method which doesn't involve trial and error. Taking center as D, you can draw a arc of length 7 cm to get the point B. For this, instead of trying to get that one required point of distance 7 cm from D, let us explore a way of getting all the points of distance 7 cm from D. We know that what this shape is. Step 3. Method 1. You can draw like this, but this is odd. Instead of drawing the whole circle, you can draw a part of the circle known as arc. Like this, you will get the point B at a distance of 7 cm from D. Construct a circle of radius 7 cm with point D as the center. Can you spot the point B here? Remember that it is 7 cm away from point D and on the line L. Consider the point at which the circle and the line intersect. What is its distance from point D? If indeed, check your figure. What do you observe? The point where the circle intersects the line L is the required point B. Method 2. To locate the point B, was it necessary to draw the entire circle? No. We can see that only the arc near the line L is needed. So, the third step can also be done as shown in the figure below, like this. Having marked the 3 points of the rectangle, we only need to complete it. Recall that we were in a similar situation in the previous problem also. We saw two methods of completing the rectangle from here. We could follow any one of those methods. After getting the point B, you can draw a perpendicular at B like this and a perpendicular at D like this. This will be point A. Another method of doing that is, after getting the point B, you can measure distance CB using a compass and draw a perpendicular at D and cut the perpendicular such that you get the point A. Your required rectangle is here. Step 4. Construct perpendiculars to DC and BC passing through D and B respectively. The point where these lines intersect is the fourth point A. Check if ABCD is indeed a rectangle satisfying properties R1 and R2. Construct 1. Construct a rectangle in which one of the diagonal divides the opposite angles into 50 degree and 40 degree. You can draw a line DC like this. You can draw perpendicular at C like this and a angle 50 degree at D like this. This will be point B. At B you can draw perpendicular like this and at D a perpendicular like this, both meeting at A. Your rectangle ABCD is ready. 2. Construct a rectangle in which one of the diagonals divides the opposite angles into 45 and 45. What do you observe about the sides? For this, you can draw side like this. Complete this to get the rectangle. Instead of rectangle, you will get a square. Because in a square only, the diagonal divides the corner angle into 45 degree and 45 degree. 3. Construct a rectangle, one of whose sides is 4 cm and the diagonal is of length 8 cm. You have to construct a rectangle whose sides is 4 cm and diagonal of length 8 cm. You can draw one side of length 4 cm. Then you can draw perpendicular like this. You can draw a arc cutting the perpendicular like this at the distance of 8 cm. Then you can make the rectangle like this. You can name the rectangle DCBA or ABCD like this. 4. Construct a rectangle, one of whose sides is 3 cm and the diagonal is of length 7 cm. Try doing this. 8.6. Points equidistant from two given points. Construct house. Recreate this figure. Note that all the lines forming the border of the house are of length 5 cm. Solution. The first task is to identify in what sequence the lines and curve will have to be drawn. Step 1. You can draw this figure. Can you complete the figure? Try. After drawing the figure using ruler, you have to locate the point A such that you can draw an arc like this. Note that point A is equidistant from B and C. For this, you can draw two arcs of length 5 cm meeting at point A like this, such that this length is 5 cm and this length is 5 cm. Taking point A as center, you can draw a arc like this. Your house is ready. We need to locate the point A that is of distance 5 cm from the point B and C. You might have realized that this can be done using a ruler. However, this leads to a lot of trial and error. This construction can further be simplified. How? If you have guessed that this can be done by the use of compass, you are right. Go ahead and explore how the point A can be located without trial and error. There is a similarity between the problem of finding point A in this problem and point B at step 3 of the second solved example of the previous section. See page 209. Step 2. Draw a curve that has all its points of 5 cm from the point B. The circle centered at B should be with 5 cm radius. Does this help in spotting the point A? Construct and explore the figure. The point A can be located by finding the correct point on the circle that is of distance 5 cm from the point C. Again, this can be done using a ruler. But can we use a compass for this? Step 3. Method 1. Take a radius of 5 cm in the compass and with C as the center, draw a circle. Are you able to spot the point A? Yes, the point A is here. Check the figure of your notebook. What do you observe? You observe that point A is at a distance of 5 cm from B and 5 cm from C. Taking A as center, now you can draw this arc. See the point at which both the circles intersect. How far is it from the point B? How far is it from C? Thus, this is the point A. Think, was it necessary to draw two full circles to get the point A? We only needed part of both the circles. Method 2. So the point A could have been obtained just by drawing arcs of radius 5 cm from points B and C. Like this. Join A to B and A to C by straight line. Like this. Your house is ready. Having obtained point A, what remains is the construction of the remaining arc. How do we do it? Can we use the fact that A is of distance 5 cm from both points B and C? Yes. Step 4. Take 5 cm radius in the compass and from A draw the arc touching B and C as shown in the figure. Like this. The house is ready. Construct. 1. Construct a bigger house in which all the sides are of length 7 cm. 2. Try to recreate a person, baby wave and eyes from the section artwork using ideas involved in the house construction. 3. Is there a four-sided figure in which all the sides are equal in length but is not a square? If such a figure exists, can you construct it? Yes, you can construct it. Yes, you can construct it. You can draw a side of any length like this. Take this length on the compass using a scale. Draw an arc like this, and like this. Since this side is equal to this side and equal to this side and this side, you can say it is possible to construct a four-sided figure whose all sides are equal but corner angles not equal to 90 degree. Hints. A. Eyes from 8.1 artwork and construct 2 above. Part of the construction is shown. Observe it carefully. You will see two horizontal lines drawn lightly, like this. In geometric constructions, one often constructs supporting curves or figures that are not part of the given figure but help in constructing it. The technique to draw the upper and the lower curves of the eye is the same as that used in the figure a person. Points A and B are the locations where the tip of the compass is placed when drawing the curves of the eye. Note that the upper curve and the lower curve should together form a symmetrical figure. For this to happen, where should these points A and B be placed? Make a good estimate. Try to get the eyes as symmetrical and identical as possible. This might need many trials. B. From construct 3 above. For the purpose of construction, let us take the side lengths to be of 5 cm. Consider this figure. 5 cm, 5 cm. You can draw like this. We need to identify only one more point to make this four-sided figure. That point, let us call it D, should be 5 cm from both B and C. How can such a point be found? Can any of the ideas used in the house problem be used here? Yes. From B and C, you can draw two arcs of length 5 cm each, like this. You will get a figure whose all sides are equal but corner angles are not equal to 90 degree. This type of figure is known as rhombus. Summary. All the points of a circle are at the same distance from its center. This distance is called the radius of the circle. A compass can be used to construct circles and their parts. A rough diagram can be useful in planning how to construct a given figure. A rectangle can be constructed given the length of its sides or that of one of its sides and a diagonal. For more videos, you can subscribe NCERT video. Thank you.